Thank you, Sana. That was great. How are you? How you doing? It's so great. I have to tell you, it's like God's flashlight looking down on me, these lights up here saying, you drank too much last night, and I know where you are. So I'm going to look a little squintier than I normally do, but I trust that you're all out there on the other side. It's a wonderful pleasure to be here with all of you this morning, and a great honor to share some of the things that we're doing at Planet and some of the things we're doing with many other organizations to help accelerate a truer cost, lower carbon economy and using space to help life on Earth. Now, before we get started, however, I'm going to play a little game with you. And if any of you have ever done this with me before, you're not allowed to play. This is just for the people who are new. I'm going to show you two images on the screen, and they're going to flicker like this. And I promise you, there is one and only one difference between the two images. And when you see it, what I'd like you to do is gently and non-competitively, this is not about like beating the other tables, I'd like you to gently raise your hand and tell me when you see the change. And that is the whole of the game, okay? Do you have it? Everybody got it? Ready? 3, 2, 1. Oh, 1, 2, 3, 4, 5, 6. I'm just trying to get to 10, 8, 9, 10. Okay, now, honestly here, how many people saw no difference between those two images? I'd like you to raise your hands. Okay? I'd like you to meet the honest cohort at VERGE. I don't know what those other people are looking at. For those of you who didn't see it, I'd like you to just pay attention to this part of the screen. And I'd like you to watch as the thing that holds airplanes in the sky disappears in front of your eyeballs over and over and over again. And for those of you who did see it, remember, it took you almost 30 exposures and the voice of authority, someone who had seen it before, to tell you it was there for you to see it at all. None of us saw it in the first 10 times we saw it. And I want to say to you, the first time I was shown this, I didn't see this either. So why did we miss it? Well, we missed it for a lot of reasons. But the most important ones are human beings are very well calibrated to seeing change where we expect it to occur, at the speed that we expect it to occur, in the places and ways that we expect it to occur. Just out of curiosity, how many people here started by looking at the soldiers? How about like the tail of the aircraft? See how many hands went up? Now, none of you coordinated, but you all used the same strategies. And the challenge is that so many of the kinds of transitions that are the components of the grand transitions we need to make in this transition to the next economy are like the disappearing aircraft engine. They're invisible, they're slow, because human beings are really good at seeing change that moves like this. We're really bad at seeing change that moves like this, but we're also really bad at seeing change that moves like this. And so many of the kinds of changes that we have to deal with are those kinds of slow background changes. They're part of what brings us all here together. In fact, my favorite thinker in the Bay Area, Stuart Brand, I think captured this idea really beautifully when he said, in our society, it's the fast-moving trends that get all of the attention, but it's actually the slow-moving trends that have all of the power. And you can see that if you zoom out on Earth, because you can see the kind of flicker that we as a species put upon the planet. And I'll just show you, we'll play this game again, okay? I'm going to show you two images. They're going to flicker on the screen. I want you to see if you can tell the difference between the two of them, okay? So here you go. Ready, set, go. Here's this one, and then there's that one, right? Back and forth. Now, it's subtle. I don't know if you can tell, but humanity is having an impact on the planet. And if you just sort of zoom out and space out for a minute, you can see it. So how do we take all of those fundamental forms of change and make them visible, accessible, and actionable? Because in so doing, we can move them from being the kinds of things that have been externalities to the global economy and begin to bring them into the core of the economy. Because we don't measure what we don't value, and we don't value what we don't measure. And it's been a kind of reciprocal problem for a long time. And the way that we're doing that at Planet is with these little satellites that look like this. Most satellites are the size of school buses. They're huge, multiple hundreds of millions of dollars to billions of dollars, and many decades to build. They're the size of school buses. And a group of young NASA engineers said, we'd like to do this differently. And they went down to Best Buy. They bought a stack of these things, took them back to build a little tiny satellite you could hold in the palm of your hand, gave it to one of the astronauts who was headed to the International Space Station, and asked her to throw it out the airlock when she got there, all in secret, to see how your phone would do in space. And it turns out your phone does great in space if it's shielded correctly, and it has a camera, a computer, a GPS, a radio. It has all the things that a big instrument has in a tiny little package. And that led to a revolution in the way we design spacecraft. These satellites are only about 30 meters from end to end, not from solar panel to solar panel, but if you look this way, they're about the size of a loaf of bread. And what we've done with them is put them in a giant orbit around the Earth. They spin basically from the North Pole down to the South Pole, and as the Earth turns sideways underneath them, because each one is a camera, they collectively image every part of the terrestrial surface of the Earth every day in high resolution. So we see all the land mass, all the near waters of the Earth every day. And, and we saw them today and yesterday and the day before and the day before and tomorrow and the day after. Every solar wind farm, every field, every city, everywhere, every day. And understanding that kind of density of time series, understanding time in that very, very thinly sliced way, allows us to understand the kind of normal rates of variability of the planet. And then to be able to understand where things are changing in a way that might be really critically important. I'll give you just one example. I hope this is coming up. Let's see. Can you all see this? Okay. So here we are in the Bay Area. One of the things we then do is we take all of that data. Planet produces more Earth observation data a day than all the other Earth observation systems combined. We download it to dozens of ground stations, stitch it together, and then use the tools of artificial intelligence to extract kind of meaningful patterns from that imagery that tell us about kind of profound indicators of the planet. So for instance, we are now running algorithms that identify every building and every road in all of our imagery. So here's all the buildings and all the roads in the Bay Area, and not just in the Bay Area, but actually this is all the roads and all the buildings in the world last month, everywhere. And if you can do that every day and every week, you can get a perspective on the expansion of the human footprint, the growth of clean and green infrastructure in a way that is absolutely unrivaled. So this is the beginnings of a fundamental transformation in the transparency of what's going on the planet, and that itself is the next important step. It's the sort of foundational step in getting us to a truer cost economic system. And that's because of something we think a lot about at Planet. I hope you all can see this. We think there's a shift underway from an era that's defined by what we think of as big data to an era of big indicators. So we have this massive revolution in new forms of information. Sensors in your pocket, in the sky, in space, much too much information for human beings to look at. There's a companion revolution, however, in artificial intelligence, machine learning, computational vision, all of the kind of statistical analysis tools that allow us to pull out meaningful signals from that data. And if you can do that reliably and consistently, you can begin to build new kinds of indicators that tell you about the health and vitality of the world's most fragile and essential systems on which all life depends on a kind of daily basis. You know, we don't have a Dow Jones for deforestation or a NASDAQ for nature, but we must. We have to be able to bring all of this capital that's sitting on the sidelines into the world's most essential problems, and it won't work unless we have indicators that are responsive to change. Because once you get those new forms of indicators, then you can build new kinds of instruments, the kind of big instruments, that channel that capital to the world's most challenging problems and the most essential problems. That's what everybody here is really in the business of doing. There's a lot more value at the top. All the information is at the bottom, and the work that we're undertaking with many others is about translating that raw information into that kind of value. A lot of our focus is on the Sustainable Development Goals. We've done a kind of independent analysis and determined that our data is relevant to helping to measure 13 of the 17 goals. But enough about these sort of abstractions. Let me just show you what it actually looks like. So I'd like to show you a picture of deforestation in the Amazon. This is sped up. So you can actually see the aircraft engine at work in this imagery. On the right-hand side, you actually see the process of deforestation over a few months in the Amazon. But just as importantly is what happens just for a blink on the left-hand side of that image. You see those sort of spider tendrils that come out? Those spider tendrils are the new roads that are going in ahead of the next wave of illegal deforestation. And if you can capture them, if you can understand in detail the kind of mechanics of the system, you can begin to interdict right at the point when bad behavior is going to occur. And in fact, actually, you're going to hear in the next panel an incredibly detailed collaboration around this kind of issue. Now, that's not the only thing we can do with deforestation. What we can then do is take that data about deforestation and combine it with some other remote sensing data. We work with a team that's now at Arizona State University. They were at Carnegie. They fly these special planes over the forest canopy that use LiDAR technology. This LiDAR is the same tool that we use for self-driving cars that give the cars a sense of what is happening in space around them. When you aim them at the forest canopy, what you get is a picture of the forest canopy's mass, and from its mass you can get a sense of its biomass, and from its biomass you can get carbon. And then when we build algorithms that correlate that carbon assessment to our satellite imagery, what we can begin to do is build machines that identify when deforestation has occurred and calculate how much carbon has been lost in the process, producing a kind of independent assessment, a continuous indicator, a big indicator of forest carbon. And that's what you're seeing happening right here. Every time we see an act of deforestation, we can calculate what it means for carbon. And that's just the beginning. We're using this technology right now over the whole country of Peru and actually building forest carbon indicators with some academic partners at Arizona State. Now what we're doing is working with another coalition of actors to build something called the California Forest Observatory, which will use some of the same techniques to map every single tree dynamically in all the forests of California so we know where all the fuel load is. That's important for all kinds of reasons. This will be a fundamental game changer. It's work we're doing with Vibrant Planet and with an organization called SALO, both of whom are here, by the way. So if you see them, you should ask them about this work. It's absolutely incredible. Now, there are other things we can do that are sort of surprising. With an organization that's also working with Google called Carbon Tracker, you can look at things like this. So this is here's just a very quick time series of the operations of a typical coal-fired power plant. Now, it's a little hard to see, but just on the upper right quadrant, what you can see is there's a pile of coal, because the fuel that goes into the facility is actually kept in a giant pile right next to the facility. And you can run exactly the same kinds of algorithms that tell you how much coal is in the pile to get a broad sense of what the throughput of the coal-fired power plant is. And these plants go up and down, as many of you know who are working at the forefront of the clean economy. If you can do it for one, in principle, you can do it for all. So again, we can get a sense not just of what's the growth of the clean economy, but what's happening with the rest of the hydrocarbon economy. Next for us, on the other side of this, and very early in this process, we've just announced with the state of California, the Jet Propulsion Laboratory, the Office of the Governor, and our friends at Bloomberg, and a whole suite of other related philanthropic organizations, that we're beginning this process to build the next generation of sensors, which are going to bring the same kind of precision and capabilities to our ability to understand methane and other related carbon climate emissions indicators that are going to open up entirely new vistas. Now, this is a few years away, but we are being public about it because we're really racing to fill in the kind of information and the missing gaps. There are other things we can do with this, and I'll just mention one or two more in my last few minutes. You can do incredible things monitoring agriculture. Now this, I don't know if any of you know what this is. These are corn growers in Iowa. And what you're seeing here is a continuous yield estimation of how much corn is being grown and at what level of maturity, so you can do crop estimates. That's incredibly interesting. You know, if you're doing nitrogen-based agriculture, nitrogen fertilizer-based agriculture in Iowa, all of that nitrogen fertilizer runs off, especially in an era of climate-exacerbated flooding, comes down the Mississippi and creates a dead zone the size of New Jersey. So if we can de-intensify how much of that fertilizer is used, we can begin to kind of and the production of that fertilizer is unbelievably carbon intensive. We can begin to shift things. And just as interestingly, with some other organizations, like the one that's just spun out of Stanford called Atlas AI, we can begin to apply the same techniques to smallholder farmers in many places in the world, including in sub-Saharan Africa, where 80% of the crops are grown by very, very small farmers that are nowhere near as efficient and don't have the same kinds of information services. The last example I'm going to show you, just to give you a sense of what's coming, is how we use these tools to build a new form of climate risk indicator for disasters, and in particular for floods. So what we do here is we take all of that daily global satellite imagery and we use the tools of supervised machine learning, artificial intelligence, to extract maps of where all the monthly growth is in buildings. You saw that at the beginning. Then what we do is we overlay a model that tells us about where all the flood risk is, the elevated risk of flood associated with climate change. And that gives us a picture of urban risk. Where are people moving into cities in places where they're actually moving into danger? Now, the thing that's important about that is there are many places that we do that in the United States. There are many places we do that in Europe, but there are thousands, tens of thousands of places where we don't do it at all for people around the world. And I'll give you just one example. This is the city of Bangui in the Central African Republic. Here it is in October of 2017. Here it is in the spring of 2019. And I hope this, you can go back and forth. You can see there's some seasonal variation. There's also some growth in that city. We use those tools of machine learning, again, to extract where are all the hotspots of growth. This is where all the growth is occurring. And what you'll see here is there are these places, like in this little red box, where there's a lot of growth right in the wrong area. In fact, if we zoom in on that area, which happens to be in the crook of a river, you can actually see it with your own eyes. You can actually watch back and forth. I should rename this the flicker presentation. I just flick back and forth between stuff and you get a general sense of what's going on. So we overlay this. This is the growth rate. And that in turn tells us where all the people who are most at risk are. And that's the beginning of new forms of municipal climate resilience bonds. It's the beginning of new kinds of microinsurance instruments. It's new ways of financing and beginning to bend the indicators in the right direction. This is just the beginning, and I can tell you if there's one fact we've learned at Planet, it's that as the satellite folks, we actually don't know all the applications, and I would guess there's a dozen really good ideas in this room today about how to use these technologies that no one's ever thought of yet. So we'd love to hear from you about that, and I want to say just as a member of the VERGE community and as a friend of so many organizations that are in this room, it's a great honor to share this work with you. So thank you very much.